Hello, everyone. You're welcome to this class today. This is our first week, and it's going to be a very nice one. My name remains Shegun Oke, and I'll be facilitating linear algebra 2, MTH 212. And here is my email from, if you want to reach me, you can still send me your request or any email or any information you want to pass across. I'm from mathematics department, the Faculty of Science. As we all know that this course is a kind of fundamental courses that need to be checked and need to use. Here we have linear algebra 2, be taking us through the introduction, the course objective, the units, and so on. We have our introduction here that says during the introduction during the course of the unit, I will be explaining what it means that about mapping between two vector space called linear transformation, and the importance of the mapping can be realized from the fact that in the calculus of several variables, every continuous differentiable function can be replaced to a first approximation by a linear one. We have nonlinear, we have linear, but in this case, we are dealing with linear. The fact is that the reflection of the general principle that every problem on the change of form of quantity under the action of several factors can be regarded to a first approximation as a linear problem. So when you have a problem, what this area is telling us is, before you move to the nonlinear, you first of all reach linear, and from there we will be able to start from the linear. After the first approximation, which is linear, they begin to have all these quadratic, all these complex one, and so on and so forth. And it often turns out that the gifts of adequate results also in physics, in engineering, in computer science, in machine learning, all these are important, and they are even in construction, they are important to know the change of coordinate system. This require of the study of linear transformation. In this unit, we will study linear transformation, as I said, and their properties, as well as two space associated with linear transformation, and the properties, as well the space associated with linear transformation, and so on in different dimension will also be involved. So as we move on, of the introduction, from then we'll move on to the other aspects of the courses. Here we have our objective is, at the end of the day, all of us, all the students register for this course will be able to verify the linearity of the certain mapping between the vector and space, construct a linear transformation. You'll be able to construct the linear transformation with a certain specified property. You'll be able to calculate the rank and nullity of the linear operator. You'll be able to prove and apply the rank nullity theorem to be able to solve some real life application. You'll be able to define the isomorphism between the two vector space. And then you'll be able to show that two vector space are isomorphic if and only if they have the same dimension. That is, are we talking about how many dimensions? Are we talking about m by n, m by m dimension, different dimension? And you'll be able to prove and use the fundamental theorem of homomorphism. So we have the course content for the unit 1. The course content for the unit 1 will be talking about transformation, linear transformation, space associated with a linear transformation, the range space and the kernel, rank and nullity, some types of linear transformation, then homomorphism theorem. So then for the linear transformation week 1, I want to employ you for this first week to try as much as possible to read the subtopic in the unit 1, namely the one that I've mentioned above. Still the same thing, try and read them. Then we have some of the class activities also, to be able to solve class activities, and from there we'll be able to see how can we introduce ourselves. If you have any question, you can ask within the group and we'll be able to sort it out. I want to welcome you once again to the first week of linear transformation 1 for this particular module. Thank you.